Our next presentation will be by Jared Goplin. Jared is a PhD student in the agronomy and agroecology at University of Minnesota. He's working on his PhD focusing on improving control of herbicide-resistant giant ragweed by managing the weed seed bank. Jared is originally from Canby County, which he grew up and is still involved in the family farm, raising corn, soybean, alfalfa, wheat, alongside a cow-calf herd. With that, I'd like for you to help me welcome Jared.
Well, thank you for the introduction, and it's good to be here, representing Minnesota here. So I'll just kind of get started here. So you've heard, if any of you were at the last presentation, you kind of heard a little bit about herbicide resistance. It's kind of on everybody's mind. It's certainly becoming a bigger issue. So obviously there's been a number of weeds that have evolved resistance to these herbicides. That threatens obviously the herbicides for weed control, since they're not going to be effective anymore. Also you think about some of these herbicide resistant traits. If you think about 2,4-D and dicamba tolerant crops, if the weeds are already resistant to those products, those traits are essentially worthless. So it becomes very important to protect some of these products, and it forces us to look at some of these other mechanisms to control these weeds. And just to give you an idea, it's been estimated anywhere from $11 to $20 per acre in increased production costs with dealing with some of these resistant weeds. But you can obviously imagine some scenarios where that cost would be significantly higher than that. So that brings us to the main question of how do we manage these resistant weeds? Obviously herbicides have been fairly effective in the past. There might be another product that can help you out. But what it comes down to is we need to start looking at some of these other options. Something like tillage, or maybe even pulling out your old rotary hoe out of the shed or cultivator. And then ultimately, if we become that desperate, it might come down to hand weeding. But I guess if it was up to me, I'd just as soon cultivate instead of hand weed. There's also these things that I'll refer to as cultural practices, and they include things that you see listed on the screen. So things like row spacing, planting date, crop rotation, try to manage that weed seed bank. And then also, if you're planting annual crops, maybe think about incorporating a perennial like alfalfa. And these are all things that aren't going to necessarily, directly kill the weeds, but they're going to at least help improve control by suppressing the weeds in some way. So for the sake of today's talk, I'm going to kind of focus on these bottom ones. And the weed I'm going to kind of use as an example is giant ragweed, since that's one of the weeds I've been dealing with for some of my research, and is becoming a very big problem in Minnesota. So those of you familiar, giant ragweed has been a pretty significant agricultural weed for quite some time. It's very highly adapted to corn and soybean systems. It tends to be difficult to control with pre-emerge herbicides because it emerges really early in the growing season, typically before you're planting or those pre's are going on. And then also it's very large seeded. If you see the photo on the right here, you can see it's about the same size as a soybean seed, which allows it to emerge up to 6 inches in the soil, kind of puts it out of that herbicide band and makes it a little more difficult to control. Giant ragweed also has developed resistance to multiple herbicides, as you might have saw in one of the last presentations. In Wisconsin, I know it's resistant to both ALS and glyphosate independently, but in Minnesota we have multiple resistant plants, meaning we have resistance to both ALS and glyphosate in the same plant. And these resistant species are becoming quite widespread across Minnesota and the greater Midwest. So this figure here just kind of shows you and reminds us, the life cycle of annual weeds. So for all annual weeds, you start from that weed seed bank. That seed will germinate, emerge, and if that weed is able to progress through the growing season, produces viable seed and starts that cycle all over again. So for the research we did, we were interested in how crop rotation can influence some of these aspects of the seed bank. So referring to both the seed bank degradation, then also the emergence patterns to see how crop rotation can affect these. And then look at both of those and see how they can maybe help improve our weed control. So the study took place down in southeast Minnesota by Rochester. And at the location, we had a farmer that was having significant difficulty controlling giant ragweed. And it turned out it was resistant to both glyphosate and ALS. So we established this crop rotation research there. And the next couple of pictures here are going to show you kind of the level of resistance that we're dealing with. So the beginning of June, we went in and applied the labeled rate of glyphosate on the left and untreated on the right. And you can see there was a little bit of suppression of the giant ragweed, but certainly not acceptable control. And if you take a look at ALS for this figure, or this picture, we used first rate. And you can see once again on the left picture that ALS really isn't doing a whole lot compared to the untreated on the right. So a very significant level of resistance in this population. And I should just also mention that the pictures were actually taking place right next to each other. So for this study, we had 6 different crop rotations that I have listed in the graph here, or the table. And they're all fairly common to the Midwest. So you have continuous corn, variations on a corn-soybean rotation. The 4th incorporates wheat into that rotation, spring wheat. And the 5th is atypical rotation, where we just have a single year of alfalfa in a corn and soybean system. But we wanted to see if just even a single year of alfalfa might have an effect on some of these weeds. And then the 6th is 2 years of alfalfa followed by corn. So just short 3-year rotations just to see if we can see any differences in that short period of time. Since we did have resistant weeds, we did plant corn and soybean, or Liberty Link corn and soybeans, just to control those weeds. And if we did have weed escapes, we maintained what we call a zero weed threshold, meaning no weeds were allowed to go to seed, so that we're able to get a better understanding of the weed seed bank degradation. So here I'll come back to this figure, and just to kind of give you an idea, we're going to start talking about the seed bank degradation. So what's happening kind of below ground. So there's a few ways that we can degrade the weed seed bank, and this really goes for all weed species. So the first and easiest to think about is emergence. If you're going to have that, if that seed's going to emerge, obviously it's leaving that seed bank and it's not going to be a problem in the future. But then we also have these other things that you can't really see, which include things like seed predators, so some rodents or birds that might be eating the seeds and removing them. And then we also have soil microbes that are breaking down the seeds. So stuff like bacteria or fungi, some of the same microbes that are breaking down your crop residue are also going to be having an effect on the weed seeds. Previous research has shown that crop rotation can increase this activity of microbes and therefore increase seed degradation. So we're really interested to see if crop rotation might have an effect on this. So to study the seed bank, basically what we did is we went in the first year and the third year, just took soil samples and counted the weed seeds in those soil samples. And this graph here shows you the crop rotation treatment on the x-axis and the percentage of the giant ragweed emerged on the y-axis. And this is showing the depletion for giant ragweed. And as you can see, there's a very high level of seed bank depletion in just 2 years, so between year 1 and year 3 of that crop rotation. And there was no differences between any of the treatments like we thought there might be. And overall, there's 96% seed bank depletion in just 2 years, which we thought was pretty significant. And really what that tells us is if we can intensively manage this system for just 2 years, you can see a very high level of seed bank depletion in a short period of time. Now that extra 4% might continue to cause problems, but at least you're getting a start somewhere. One of the interesting things we did notice with these different crop rotations is that, like I mentioned previously, one of the ways you can degrade the seed bank is through emergence. Now these blue bars that I'll just add on top of the orange ones show you the percent of that depletion that was due to emergence. And you can see in those first 3 treatments, almost 100% of that depletion was due to emergence in the corn and soybean rotations. So, like I said before, giant ragweed is very adapted to corn and soybean systems, so it isn't really surprising that we're seeing very high amounts of emergence in that system, or in those systems. But then if you look at some of these more diverse rotations, so the ones that have wheat or alfalfa for either a single or 2 years, you can see about 60 to 70% of that depletion was due to emergence in the alfalfa and wheat rotations, the annual rotations. But that 2 years of alfalfa really suppressed emergence, and only about 41% of that depletion was due to emergence, which tells us, there's some of these other factors that are playing roles, like microbes, or it could be, some other way that this seed bank is being degraded. Another example of how this could be occurring is through just seedling mortality. So it could be, with the differences in tillage in that alfalfa system, there's less tillage, could be a little more compacted soil, and it could be that those seeds are germinating but aren't able to emerge due to reasons such as that. So to really summarize and put this into words, if you're able to maintain a zero weed threshold, at least for giant ragweed, you're going to see 96% seed bank depletion in just 2 years in any of the crop rotations. But, the million-dollar question is, well, how in the heck do you maintain a zero weed threshold, right? So one of the examples I'll continue to go into is planting alfalfa. So now, coming back to this figure, I'll talk a little bit about emergence and how crop rotation had an effect on emergence. So this figure here, once again, has the crop rotation on the x-axis, but now the y-axis is going to be seedlings per square meter. And basically, this just shows you the total emergence of giant ragweed in the second year of these rotations. So in year 2, we had the most diversity in the crops that were out there. So we had all 4 crops that were in our rotations. So it just gives you a really good example of what we saw for total emergence in these systems. And the 2 treatments that really stick out here are the second one, this corn that was planted into the soybean stubble, had the greatest emergence, which is something important, and you should probably keep in mind, especially if you're dealing with giant ragweed, telling us that some of the soil environmental differences, soil residue, could be having an effect here. So when you plant corn into the soybean stubble, we saw more emergence. So something just to maybe keep in mind and be ready for. The other treatment that really sticks out is that last treatment, and that's the second year of alfalfa. So in established alfalfa, we saw significant reductions in giant ragweed emergence, which also isn't that surprising because this is a true perennial system. So you're not going to have, or that giant ragweed isn't very evolved for that type of system, so it's really suppressing that emergence. So just to put that into words as well, once again, that corn planted into the soybean stubble had the greatest emergence. And in that established alfalfa treatment, we saw 5 to 13 times less emergence in that treatment than any of the other crop rotations. And the weeds that do emerge, aren't as big of a deal because, just with your regular cutting schedule, you're going to be able to clip those plants off and prevent any weed seed production just through your regular harvest schedule. There's also a number of other benefits to planting alfalfa. So along with these crop rotations that we had for the study, we also took crop yields and monitored all the crop inputs and outputs of the system. And using the average prices received in Minnesota for all these crops in 2012 to 2015, so you can see the prices listed here underneath the graph. But so about $4.50 for corn, $11.77 for beans, $6.40 for wheat, and $166 a ton for alfalfa. This is our average net yearly income, or net returns. So we have the crop rotation on the x-axis and then the dollars per acre per year on the y-axis. And you can see on the far left that 2 years of alfalfa followed by corn, even in the last 4 years with quite high commodity prices, we still had the greatest net yearly returns. But, really the last 4 years is quite a bit different than what we're looking at for prices currently. So what I did is just took the same crop yields that we got over the last 4 years and just used current crop prices. So I took the national price index from last week, so $3.27 for corn, $8.11 for soybeans, $4.63 for wheat, and $120 a ton for alfalfa. And you can see, with these more current or realistic prices, that alfalfa treatment is still the obvious winner in terms of average net returns per year, coming in at around $70 per acre per year. And one of the reasons for this is that, in that corn following the alfalfa, so we followed University of Minnesota recommendations, which says that, you shouldn't need any additional nitrogen application, which saves, close to $100 per acre. And that's one of the reasons why we saw that better net return. So as we move forward in some of these, a little bit tighter system, where we're going to have to monitor some of these inputs, certainly alfalfa could be a viable option. And also, if you're dealing with some resistant populations, especially in soybean systems, it's very difficult to control, and it might be increasing your production costs even further in that soybean or corn systems. So really what it comes down to, if you're someone who grows alfalfa or some of your clients grow alfalfa, you might want to think about planting it in fields that you're having trouble controlling weeds with. It's more competitive, you have less reliance on herbicides. But what if you don't grow alfalfa, or what about the years where you're not in alfalfa? Then what do you do? So I'll talk a little bit more about emergence patterns and how you can maybe change your timing of some of your field operations to try and improve control. So basically in the same study, we documented the emergence timing as well. And across all the treatments, this shows you basically what giant ragweed emergence looked like. So you have the date of the year on the x-axis and then the percent emerged on the y-axis. And where you see this arrow or the percentage on top of the bars just shows you the cumulative emergence. So you can see at least for giant ragweed, it emerges very early, beginning of May, peaks around the middle of May or towards the end, then tapers off. So one of the things you can think about in terms of improving control is, rather than having that early planting date like you maybe would like to, think about delaying planting even a couple weeks just to allow a little bit more of that giant ragweed to come up. And then if you're going to go through with a passive tillage or a burn down application, you can just hit more of those giant ragweed plants that are emerging earlier. And specific to tillage, there's really no effect that tillage has on emergence, so it's not going to stimulate any additional emergence. So you can feel, pretty good about your control with tillage. But then the other trade-off is crop yield. So you want to have an earlier planting date so you can achieve, your maximum crop yield. So basically, what this red line here that I just added shows you the percentage of your maximum soybean yield on average. So obviously with your earlier planting date, you're going to achieve about 100% of your yield potential. And as you delay that planting date, you're going to lose some of that yield potential. With the earlier planting date, you might have a little bit more variability in that yield, just depending on weather events. But for the most part, that's when you're going to see your greatest yields. And just to go through with that May 28th example, so if you're going to wait till May 28th, to go through and with a passive tillage before planting, you're going to get about 77% of the giant ragweed is going to be controlled with that tillage. And you're only going to lose about 8% of your crop yield. So, just kind of start to weigh some of the costs and benefits of some of this timing, or how timing can help you out a little bit. Also, with a delayed planting date, you're going to have a little bit better crop emergence, which is going to allow that to be a little more competitive with some of the weeds that you're dealing with. So now I'll start to summarize a little bit and kind of bring this all together with some of the other weeds that you might be dealing with. So what does this mean in terms of integrated weed management? Well, I like to think of it kind of as a game of percentages. How much do you want to rely on your herbicides? As you may have seen some of the previous presentations, as these weeds become more resistant, those herbicides aren't going to be as effective, so you might not want to rely on those quite as heavily as in the past. So just to continue and go through the example I gave you before, rather than having that earlier planting date, even if you have a relatively effective pre, by the time that pre wears off, you're still going to have quite a bit of ragweed to deal with, or other weeds for that matter. But if you think about delaying the planting just a little bit, go through with a passive tillage or an effective burn down before planting, by the time your pre is wearing off, you're only going to have to deal with 5 to 10% of the giant ragweed at least after that date and time. And then in terms of your post applications, rather than having to follow that planting date with an early post pass, you can also delay that post application a little bit. And you're going to have to deal with less weeds, and then they're probably going to be more uniform in height, so it's going to be a little bit better control with those later post applications. And also, certainly if you want to incorporate cultivation or some other practices, they'd be effective as well. But then, all right, so it's not quite that simple. If everyone just had giant ragweed to deal with, you probably wouldn't have jobs. So what does this mean with some of these other weeds? So just a couple other common ones, like water hemp or lamb's quarters. So the shading here shows you kind of when they're going to be emerging and what this later planting date might mean for some of these other weeds. So now, those post applications that were delayed might do a little bit better job on controlling, especially your late emerging water hemp, or maybe your later emerging lamb's quarters. So they might be a little bit more effective on some of these other weed species. And then also in terms of your pre, if you had that earlier planting date, your pre is probably not going to do a whole lot on that late emerging water hemp. But if you delay that date even a week or two, you're going to extend that residual activity a little bit longer and might get a little bit better control for some of these other weeds as well. So, take-home message. If you can intensively manage, prevent any weed seed inputs for 2 years, at least with giant ragweed, you're going to see 96% depletion. And for some other weed species, it might be a little bit longer, but certainly somewhere to start. How do you maintain that? Well, one mechanism is through crop rotation. We saw fewer weed escapes in the alfalfa. There's less total emergence, and it's more competitive. Your harvest schedule is going to eliminate any seed production. I didn't really talk about wheat much, but you can use different sites of action, specifically the growth regulators that are more effective at controlling at least giant ragweed. You can also alter planting date in your corn and soybean systems, just even a week or so. Maybe wait if you have one field that's really bad with a certain weed, just leave that field till last or something. Even that extra few days can really help improve control. So with that, hopefully I didn't go too far over.
No, you're not over at all.
Perfect.
Any questions?